In our previous video, we looked at the concept of linear kinematics. At the end of the video, I mentioned that was just the concept. We are going to use mathematics to describe motion properly. So in this video, we are looking at equations of motion. Don't forget that we are still looking at linear motions. So the equations we are going to look at here are all for linear motion or linear kinematics. Now, Isaac Newton developed these equations or formulas to describe the object moving in a uniform acceleration. Now, as this topic has everything to do with describing of motion, we are going to use mathematics and equations to describe the motion of an object, and we are going to use the quantities that we mentioned earlier in our videos, such as the speed, time, distance and displacement, and acceleration to discuss or describe the motion of object in a straight line. In fact, if you know any other quantity that we can use to describe the motion of an object in a straight line, please let me know in the comment section because I am looking for one. So now let's consider a car moving with an initial velocity u, accelerating at a constant rate a to a final velocity v using a time t to cover a distance s. Now the acceleration here is supposed to be constant. For equation of motion and for description of motion, the acceleration is supposed to be constant. So we are talking about motion of an object with constant acceleration or uniform acceleration. So we know acceleration is constant. Time too, you can speed time, you can slow it down, it moves at a constant rate. Distance covered is going to be the same distance covered, but the issue we are having here is the velocities. We have initial velocity, we have final velocity. You remember we only talked about velocity, but here we are seeing two velocities. So since we are having two velocities, we are even likely to get more velocities in the course of this journey. But then for the sake of our formula, we are sticking to just two velocities, the initial velocity and the final velocity. In this case, instead of looking for velocity, we rather look for average velocity. So we find the average velocity, V average, as the sum of the velocities. I have two velocities here, initial velocity plus the final velocity divided by how many velocities am I adding? 2. Had it been that we are adding 3 velocities, I'm going to add the 3 velocities divided by 3. If there are 4 velocities, we are going to add the 4 velocities divided by 4. That is what average means. We sum them up and we divide by the number of entries. So since we have one acceleration, one time, one distance, and 2 velocities, we have to look for its average. So this is our average velocity. Now let's get into the equations. The most important personality in this whole topic we are discussing is acceleration, because acceleration has to be constant. So in all our calculation, acceleration must be present in our formula. And we know that acceleration, from the definition of acceleration, we said that it is the change in velocity divided by time. So the change in velocity, we have our final velocity minus initial velocity divided by time. So these are the two most important things I want us to know before we get into the equation. So let's quickly get into the equations. So let's start looking for the first equation. We have seen from here that acceleration is equal to change in velocity divided by time. All we need to do here is to make our final velocity the subject in order to get the first equation. So I multiply both sides by t and I get at to be equal to v minus u. I want to make v the subject, so I bring u this side and the sign will change to positive. At plus u equals to v. Now, it is preferred that we always write our subject on the left hand side. So I'll bring my v here to be equal to u plus at. So this gives me the first equation of linear motion. Now, when you check, three of the quantities that are required in the equation on describing motion, which is distance or displacement, velocity or speed, acceleration, and time, only three of them are here. We have velocity, acceleration, and time. Which one is missing? So the one that is missing is distance or displacement. That is what will lead us into the second equation. So let's try finding the second equation of motion. So you realize that distance is missing here, or displacement is missing here. And then displacement, from the formula of velocity, we know that velocity is equal to displacement over time. So if you are looking for displacement, that is going to be displacement equals to velocity times time. Now in this case, if you are looking for the displacement from the beginning to the end of this journey, we don't have a single velocity. There are several velocities. Started with a single velocity, probably started from zero. Then at this point, it had a different velocity, here different velocity until it gets to its final velocity. So instead of just multiplying by the velocity, we multiply by the average velocity. So you find the average of the velocities and we multiply by time to get the displacement. And we found out, or we deduced from here, that average velocity is equal to u plus v, which is initial velocity plus final velocity, all divided by 2. Therefore, I'm going to multiply by that by t. But I said that the most important thing, or the most important quantity that must be present in all the equations is acceleration. So at this point, acceleration is missing. So let's find a way to get acceleration back into this formula. So what we do is that we go back to the first equation. So from the first equation, v equals to u plus at. So in place of v here, we are going to substitute u plus at. So that gives me s to be equal to u plus, let me put that into brackets, u plus at all divided by 2 multiplying t. So I go further to get s to be equal to, have my u plus u, that will give me 2u plus at all divided by 2 all multiplying t. Okay, so now I want to simplify this, but then the easiest way I could go by this is to split this into 2. You can also decide to multiply both sides by 2 to get rid of the fraction, but then that will prolong or extend your work. So the easiest you could go is to just split this fraction into 2 and say 2u over 2 plus at over 2. Such that if you want to simplify back this same common denominator, so you just pick one and add the powers and you get back what is here. So 2 will cancel 2 and my formula is reduced to u plus at over 2 all multiplied by t. So I'm now going to expand this bracket and I'm going to get s to be equal to u times t, which is ut plus at. T is now 2, so at squared over 2. This is popularly written as s equals to ut plus half at squared. So any of these two you write is correct, but then this is the most popular. So at this point we have the second equation of motion. If you check here too, we have our initial velocity, we have time, we have acceleration, and we have displacement. Next, we are going to look for the third equation. And the third equation, we are still going to use the displacement formula. The displacement is equal to average velocity, which is u plus v divided by 2 multiplied by t, which we had here. We've already talked about that. Now here, instead of substituting for v, we are going to make t the subject in the first equation and substitute in here. So from the first equation, v equals to u plus at. So I want to make t the subject here. So I'm going to get v minus u over a equals to t. So in place of t, I'm going to substitute v minus u over a. So that is going to give me x to be equal to u plus v over 2 multiplied by, instead of t, I'm writing the whole of this. So I'm going to get v minus u over a. Now all I need to do is to simplify this relation. So to simplify, this is multiplying. So I can write s to be equal to u plus v multiplied by v minus u all divided by a, and this is also divided by 2. So when you're multiplying them, that will be 2a. Since addition is commutative, I can rewrite this as v plus u multiplying v minus u divided by 2a. Now when you watch closely, the numerator gives us difference of two squares. If you don't agree, you can go ahead to expand this, and then you are going to get what I'm going to write. So s is going to be equal to difference of two squares. That will be v squared minus u squared. As I said, if you don't agree with me, go ahead and expand and you will get this same thing. And if you want me to expand to, let me know in the comment section. I'll gladly do that. So at this point, we just want to make our equation simple. So all I need to do is to multiply both sides by 2a. So I get 2a times s. I always want my number to come first, so I get 2as to be equal to v squared minus u squared. As we did in the first equation, we want our v to be the subject, so I take the u to the other side. So I get 2as plus u squared equals to v squared. And as I said, let's always bring our subject to the left hand side and put whatever is left on the right hand side. So that gives me v squared to be equal to u squared plus 2as, and this is the third equation of motion. So anytime you are given any question where you are to describe the motion of an object, you are either going to use the first equation, the second equation, or the third equation. So let's meet in the next video where we are going to look at interesting examples